Here's a video where I explain things that are a bit complicated but also really important to understand. Today we're going to talk about AI agents. What they are, why they're important, and how they're different from other kinds of AI. So let's get started. Artificial intelligence agents, or simply AI. Agents are programs that can perform useful actions in a computer simulation or in the real world through human-like interactions with their environment. In other words, they're software programs that can make decisions and take actions autonomously based on the information they receive from their environment. They can perceive their environment through sensors, reason about the state of the world based on their perceptions and plan, and execute actions to achieve their goals. In the world of artificial intelligence, there are many different types of agents. For example, software agents are programs that run on a computer and can perform tasks such as searching the web for information or filtering spam emails. They typically operate within a specific scope or domain and use algorithms to process information and make decisions. Then there's intelligent agents, which are more advanced than software agents and can perform more complex tasks. Intelligent agents have the ability to learn from their experiences and adapt their behavior over time. They use techniques like machine learning and deep learning to analyze data and make decisions. Intelligent agents are often used in applications like autonomous vehicles, robotics, and natural language processing. At the core of any AI agent is a set of building blocks that work together to allow the agent to function effectively. These building blocks include a number of components that work together to allow the agent to perceive its environment, reason about the state of the world, and plan and execute actions to achieve its goals. Let's take a look at each one of them. The first component is the environment, which is the external world in which the agent exists. The environment can provide the agent with information through sensors, such as cameras, microphones, and GPS. It can also be affected by the agent's actions. For example, if the agent is a robot, its actions could involve moving around in physical space. Whereas if the agent is a software agent, its actions could involve manipulating data or sending messages. Next, we have the agent's architecture, which refers to the structure or organization of the agent. It defines how different components of the agent interact and work together to achieve its goals. There are many different types of architectures for AI agents, each with its own strengths and weaknesses. Some common architectures include rule-based systems, which use a set of predefined rules to control the agent's behavior and decision-making processes. These systems are easy to understand and control, but they can be difficult to build and maintain. Then there's the other type of architecture called a connectionist system, which uses artificial neurons and networks to model the agent's behavior. Connectionist systems are able to learn from data and improve their performance over time, but they can be more difficult to understand and explain than rule-based systems. Moving on, we have the agent's sensors, which are the mechanisms that allow the agent to perceive its environment. Sensors can provide the agent with information about the state of the environment, such as the location of objects or the intensity of lighting. Different sensors provide different types of information and have different ranges and resolutions. For example, a camera can capture visual information, whereas a microphone can capture auditory information. Next, we have the agent's actuators, which are the mechanisms that allow the agent to interact with its environment. Actuators can be used to control the agent's movement or to manipulate objects in the environment. For example, if the agent is a robot, its actuators could be motors that control its joints, whereas if the agent is a software agent, its actuators could be mechanisms for displaying information or sending messages. Another key component of an AI agent is its knowledge base, which is a collection of facts or rules that the agent uses to reason about its environment. The knowledge base can be used to answer queries or to generate new facts or rules. For example, if the agent is a chess-playing program, its knowledge base might contain rules about how the pieces move on the board. Next, we have the agent's reasoning module, which uses the agent's knowledge base and perception of its environment to generate new knowledge and make decisions. The reasoning module can use techniques like logic and inference to draw conclusions from the information it has available. For example, if the agent is a chess-playing program, its reasoning module might use the current state of the board and its knowledge of the rules to determine which moves are legal and which moves would be most advantageous. Another essential component of an AI agent is its learning module, which enables the agent to improve its performance over time by learning from its experiences. The learning module can use techniques like machine learning and reinforcement learning to identify patterns in the data and make adjustments to the agent's behavior accordingly. For example, if the agent is a self-driving car, its learning module might use data from previous driving experiences to improve its ability to navigate new environments. Then we have the agent's communication module, which enables the agent to interact with other agents or with humans. The communication module can generate natural language, communicate through speech, or send messages. For example, if the agent is a customer service chatbot, its communication module would enable it to understand and respond to customer inquiries. And finally, we have the agent's interface, which is the point of contact between the agent and the user or the environment. The interface can be a user interface, like a website or mobile app, or it can be a communication interface like a messaging platform. The interface allows users to interact with the agent and provide input or feedback. So these are the building blocks of an AI agent. Now, let us take a look at some examples of AI agents to better understand how these building blocks come together to enable autonomous decision-making and goal-oriented behavior. Let's say we have an AI agent that is designed to play the game of chess. This agent would need to perceive the state of the game through its sensors, which could be implemented as a camera and image processing algorithms to capture the position of the pieces on the board. Based on this perception, the agent would need to reason about the game state to determine the legality of moves and evaluate the potential outcomes of different moves. This reasoning process could be implemented using a knowledge base of chess rules and a reasoning engine to infer possible moves and their consequences. The agent would then use a learning module to improve its decision-making over time by analyzing its past games and identifying patterns and areas for improvement. Finally, the agent's interface would allow it to communicate its moves to the game engine or another player. Another example of an AI agent is a self-driving car. This agent would need to perceive its environment through a combination of sensors, such as cameras, LiDAR and radar to detect objects and understand the layout of the road. The agent would then use a reasoning module to plan a safe and efficient route, make decisions about speed and steering, and predict the behavior of other vehicles and pedestrians. A learning module would enable the agent to improve its driving skills by learning from human drivers and previous driving experiences. And the agent's interface would allow it to communicate with other vehicles and infrastructure such as traffic lights and stop signs. A third example of an AI agent is a virtual assistant like Siri or Alexa. This agent would need to perceive user requests through speech recognition and natural language processing. Would then use a reasoning module to understand the intent behind the request and retrieve relevant information from its knowledge base. A learning module would enable the agent to improve its understanding of user preferences and context over time. And the agent's interface would allow it to communicate with the user through speech synthesis and other modalities. Now that we have a better understanding of what AI agents are and how they work, let's talk about why they are important and what makes them different from other types of AI. AI agents represent a paradigm shift in the way we think about and develop AI systems, instead of relying on handcrafted rules or human intervention. AI agents can learn from data and experience and adapt to new situations autonomously. This autonomy and adaptability are what make AI agents so powerful and potentially transformative across a wide range of industries. One of the key differences between AI agents and other types of AI is that agents are goal-oriented, meaning that they are designed to achieve specific objectives or perform particular tasks. For example, a chess-playing AI would be designed to win games of chess, whereas a medical diagnosis, AI might be designed to identify patterns in patient data that indicate the presence of a particular disease. This goal-oriented nature is what distinguishes AI agents from other types of AI, such as those used in image recognition or natural language processing, which may not necessarily have a specific goal in mind. Another key difference between AI agents and other types of AI is that agents are situated in an environment and can interact with that environment through their actions. For example, a self-driving car AI agent would need to perceive its environment through sensors such as cameras and LiDAR, and then take actions such as steering and braking based on its perception of the environment. This interaction with the environment is what enables AI agents to perform tasks that are too complex or dynamic to be programmed with traditional software code. Finally, AI agents are different from other types of AI because they have the ability to learn and improve over time. By collecting data about their environment and the results of their actions, AI agents can use machine learning algorithms to refine their decision-making process and become more efficient or accurate over time. This ability to learn and adapt is what makes AI agents particularly promising for tasks that require a high degree of flexibility and autonomy, such as exploration or search and rescue operations. So that's all I have for today. I hope you learned something new, and I look forward to your comments and feedback. As always, thanks for watching, and I'll see you in the next video.